Okay, so welcome to my little home studio. So I appreciate you letting me do this, and I'm going to show you around just a little bit, so you can see this because you don't get to see this very often. This is my home studio, um, basically a bedroom a downstairs bedroom or area that we converted into a bedroom. It's not set up perfectly. The acoustics are decent. But I would change some things if I could, but I can't. So anyway, let me show you around. So this is my studio. I have a really cheap mic right here. This is it's a $35 mic. It's made in China, and but the specs are pretty good and it sounds pretty good for something like this, as opposed to my more expensive microphones. I'm not going to show you all those, but this is a BM800, and I forget who makes that, a BM800, so I don't know. For $35, not bad. You can find it online, Amazon. It's pretty cool. So I'm going to actually take off my camera a little bit off of the top here so you can see around the way I'm set up. Obviously, I got headphones on, talking into the microphone here. My microphone's feeding, and it's kind of weird setup. A little mixer, and I'll show you that. I got to pull this off, and hopefully you don't get motion sickness here. I'm trying to move as slowly as possible. Okay, so now, if you look over here, I'm using this as a virtual mixer here. This is another computer running. Basically, I have a software Studio One here, running into this computer, and but let me back up. I'm out of order here. So whoa, don't get sick, don't look up my nose. This is what I'm looking at. This, whoa, I don't know why it's zooming in like that. Anyway, that's not good. Well, let's start here. So I have my monitors here, and another computer monitor. Sometimes I'll be looking left or right, and you'll see me do that. Here's my other monitor. Why is that so close? It shouldn't be that close. And I gotta get cable, a little more cable is what I was trying to do. Okay, so now over here, hopefully you can still hear me okay. So I'm running my voice in here, so you can see the level coming up every time I'm talking. So I have the microphone that's running through an audio interface called a PreSonus 2626. That audio interface is right here. You can see that right here. I'm looking at the screen so you can see. Here I have all these inputs here, and the mic preamp controls here. So you're going to hear me a little bit louder as I turn that up, because I'm not right in front of the mic. A power supply up here that helps keep my power clean. I have some mic preamps down here. There's 8 RME mic preamps. Haven't really used those yet a whole lot. And then I have some Focusrite. It's called the Octapre. So I have 16 mic preamps here, 8, and then another 16 here. So, 8. So I have 24 inputs, 24 mics, and that's connected to the PreSonus 2424, which is this, and that's connected to the back of connected to my computer via Thunderbolt 3. So it's pretty fast. Okay. So also, I'm not doing this to say, hey, I just bought all this. I bought this stuff over time, so it's not it's not something that I just add a piece by piece. And then I also have a little control room monitor thing here, so where I can adjust the levels that I'm feeding you. You can see the LEDs over here. Whoa. There, then it's just a little trombone thing. But there's a master volume here. So this controls my control room, how loud it gets in my control room. I have it on mute now, so. And I have some old gear over there, some old tape decks. There's that DAT machine. There's a MIDI, Alesis MIDI Verb. The second machine right below it, that's the digital audio tape machine. What is that? Below that is my cassette, and below here, my cassette player. And below that is like a sound module, plays some pianos. I don't use that anymore. Above that is at the very top, well, not on the top here, that's a control surface up there. And then right below that is what is called, I guess I can get a little closer. You might have to yell. That's a compressor. I don't use that much anymore. I use it when I was doing live sound. This unit right here. And then this unit right here is a Digi 003, which is it'll still work, but it's kind of obsolete. I know it's all fuzzy. Then I got some wall treatment, posters, wall treatment. Let me go to the left. Oh yeah, let me go down in front. This will back up a little bit. Let me back up. Okay, so this is my Project Mix 01. It's my audio interface here. So this is kind of like in Studio B, C24, the C24 unit in there, but just only 8 channels here. So, and it does have mic preamps back here, so I can put 8 analog signal in there, and then I can put actually I'm feeding everything into this, so you're hearing it through this. So you can see the lights move when I talk. So up here at the top. So and I use this right now as my main control. It's getting old. It's what we call a Firewire 400, which is very old. My tannoys, which I like, or I've gotten used to. Junk and stuff over there. Trombones, music everywhere. Trophies. Oh yeah, I don't know if you can see this. My Grammy's back over in a corner somewhere. There it is, in the far right, over there. Move it this way, right there. No big deal. It's a replica, so it's not the original that they get. I get the replica. Anyway, so that's my studio. And again, how long have I been doing this? Basically, I started very simple, 1998. So I've been building it piece by piece. Every piece I've had still works. So I don't know. We can talk about that. So don't get like, oh, I want to do this, and I'll have to buy everything and things like that. I mean, one of the problems with people I see is they want to buy the latest, greatest thing, and that's not always what's going to last. You have to find out stuff that's been true and tested, and before you do that. So, anyway, that's my studio. I like it. It's trombone sounds decent in here. It's fun. Anyway, all right. So I'm going to switch to the lecture here. So there's my little intro. Hopefully this will work out okay. I don't think you need to really see me. Unless you want to lose your appetite, you're on a diet or something. So, sorry, bad joke. All right, so I'm gonna maybe put me down in the corner as far as I can go. All right, as small as I can go here. All right. So tonight we're gonna talk about the properties of sound. Actually, you get a little bit of a. I just figured this out. You get subtitles down here, so that's kind of cool. All right, unless I say something wrong. Okay, so we're gonna talk about waveforms. So when something vibrates, it creates a wave, and we talked a little bit about that on Tuesday. So what is happening is you're pushing air out, and it's gonna come back in. Because air is elastic. You push it out, you've all played with a balloon, squished a balloon, and it's going to come back out. So those molecules get pushed together and they come back out. All right, so when you create a vibration, you're pushing the air out, and the air is vibrating, okay? So we measure how far that wave moves. It's called a wavelength. Okay? It's the distance between any point on a wave and equivalent point on the other. So if I go from the tip here, and here's the other tip. So if I took this particular point and this point and I stretched it out all the way, then that would be the length of the wave. Okay? So we call that the wave length. Okay? The faster or the quicker the wave goes by, the higher the frequency. So let's go to the next slide. All right. So the wave has three basic properties, and the second one is called amplitude. Amplitude, think of the word amp or amplifier. You have to increase, an amplifier increases the level of the sound. So you're talking about how loud it is. So a wave will have an amplitude, and it's measured on the height, how the height of the wave is. So on the graph, you have your wavelength, and now how high this wave goes is called the amplitude. So the higher the wave is visually here, and actually that you can't see, it is going to be louder. So, like I said, higher amplitudes are interpreted as a higher volume, hence the name amplifier for a device that increases amplitude. Okay? So wave has a wavelength, and then it also has amplitude. All right, so next. So we have a frequency. Frequency is the number of times the wavelength occurs in 1 second. So we measure this in what we call kilohertz or hertz. Okay, so if it happens 440 hertz, it's happening 440 times, and that's usually what we tune to is the note A on the piano or the orchestra will tune to A440 or 440 hertz. Kilohertz would be a lot higher. Higher frequencies are interpreted as higher pitch. For example, when you sing a high-pitched voice, you are forcing your vocal cords to vibrate quickly. So the faster the vibration, the higher the pitch, and it's measured in hertz. So obviously the hertz number would be higher. Okay, so what you're listening to this, if I say something that's unclear, write it down, come with a question on Tuesday, okay? So I might misspeak sometimes, and that happens, so I'm not a gifted speaker. I'm a goofy speaker, but I'm not gifted in my estimation. So anyway, which is moving on. So lower frequency, notice the lower frequencies, the wavelength is going to be longer and happens quicker. Happens slower. The higher the frequency, the frequency happens faster. Okay? All right. Hopefully that's clear. All right, let me move me out of the way. I'll just keep it like that. All right, so frequency, the pitch is the pitch of the sound. This is the main, you're going to have a midterm in this particular portion will be on this about frequency, pitch, and hertz. Okay, so you got to know what frequency is related to pitch. It's measured in hertz. Okay, how often does it repeat? So the frequency of the sound pressure vibrations that reaches our ears creates our perception of the pitch of the sound. We measure this in cycles per second, also commonly denoted as hertz, with a capital H and a small letter Z. These two terms are synonymous. Okay? Cycles per second and hertz. 15,000 cycles per second is the same as 15,000 hertz. Multiples of 1,000 hertz are often denoted as kilohertz. Remember I told you about that dude that was had to relate everything to drugs. So you're not going to go very far, dude, if you keep doing that. Anyway, moving on. All right. Frequency of vibration. As the frequency of vibration increases, the pitch of the sound goes up. Also, numerically higher frequencies produce higher pitches, while numerically lower frequencies produce lower pitches. Each time the frequency doubles, the pitch rises by 1 octave. For instance, if your guitar is vibrating at 110 hertz, which is an A, and you double it, it would be an A up on the 12th fret, because you chop the fret in half, right? That's because on a guitar, the length of the string on the 12th fret, I don't know if you guys know what the fret, the little frets are like the little metal braids that go across on a guitar neck. I don't have mine out right now, but that's a fret. So if you go up to the 12th fret, that's exactly 1 octave higher. So you're cutting the string in half. So now basically letting it vibrate twice as fast. So it's going to go up. The pitch will be now 220 hertz. And again, if you have that string, it'll go up to 440 hertz. So the big takeaway is this: frequency is measured in hertz. The higher the frequency, or the higher the hertz, number of hertz, the higher the pitch. So frequency is related to pitch, and it's measured in hertz. Okay? Pitch. The human ear determines pitch based on the frequency of the wave or wavelength. The shorter the wavelength, the higher the pitch. Unit of frequency, I've already said this. Cycles per second. How many times a sound wave repeats per second? 1,000 hertz. 10,000 kilohertz is 10,000 times per second. K equals kilo. The intensity of sound is also another word for amplitude. What's the intensity? So the intensity of sound is the amplitude. So the sound pressure of variations that reach our ears creates perception of how loud it is. So if there's more intensity, it's going to be louder. And we measure the intensity or amplitude in decibels, or dB, small letter D, large B. The decibel basically is telling you how loud it is. It's a logarithmic unit, so it's not exactly like, 10 dBs doesn't, so let me read this. I can't really explain it. I think they do it better, so I'm going to just read it to you. Sorry if I insult your intelligence here, but as the amplitude of pressure variations increase, the sound becomes louder. Double the intensity of sound pressure variations creates a gain of 3 dB. So if you double the intensity, so if you have what that means is this: if you have two instruments that are playing one that's playing at a certain volume, and then you have another instrument play at another volume, you don't increase it twice as much. Let's say you're playing, it happens to be playing, each one is playing 60 decibels. One plays 60, okay, it's 60 decibels. The second guy plays 60 decibels, you will perceive only a 3 dB increase in gain. So the more speakers you have increases it only by 3 dB. Like let's say if you had two monitor speakers out there, hey, just put another speaker and make it twice as loud. It doesn't work that way. It'll make it 3 dB louder if you're playing at the same volume. Okay? So an increase of approximately 10 dB is required to produce a perceived doubling of loudness. So you'd have to, it's twice as loud, you're going to have to go 10 decibels louder. So it's logarithmic. It's not like frequency where you double the frequency, it's going to be twice as high. If you double the dB, it's not going to be twice as high. It's going to be actually much, much louder. Okay? So by way of example, the amplitude of an ordinary conversation is around 60 decibels. Increasing the amplitude by 70 dB would essentially double how loud it is, increasing the amplitude to 80 dB. If you increased it to 80 decibels, then you would double again. Okay, quadrupling the original loudness. It's kind of a weird concept, but that's what's going on there. Just remember, you can't just produce the same amount of volume or double your volume by just adding another speaker playing the same loudness. It only will increase it 3 decibels. It'll sound louder, but not twice as loud. Okay. All right. Essential terms for now. An amplifier, a device which increases the amplitude of a signal. Audio is the range of sound frequencies which can be heard by humans. So if you hear it, it's audio. Of course, dogs and bats and things like that hear different frequencies than we do. Higher. And I would imagine lower, but I know they hear higher. The decibel is a logarithmic measurement of signal strength, and 1/10 of a bell. Okay, so that's a decibel. Equalization, we didn't really talk about that yet. This is the process of adjusting various audio frequencies. So I can go in there and adjust certain frequencies. I can change the amplitude of certain frequencies with an equalizer. I can increase or decrease a range of frequencies or specific frequency with an equalizer. We will get into equalization later, but anyway, I don't know why that's in here necessarily. The frequency response is the sensitivity of an audio device to various frequencies. For example, the amount of frequencies is boosted, attenuated, reproduced. So this particular microphone has a certain amount of frequency response. It can pick up some high frequencies, it can pick up some low frequencies, but how well does it pick it up? So that's the frequency response range. The speakers that I'm listening to are the control room monitors. They have a frequency response also. Okay, the range that they can play back or record. Okay, and the microphone records those frequencies, speakers play back. Same thing with the headphones. They have a range of frequency response, and we'll get into that a little bit more later. All right, some more terms that I want you to know. Gain. Gain is the amplification level of an audio signal. Now, if I went back to I'm going to move my camera here. If I come back up in here on these knobs right here, I don't know if you can see, it just says signal, but on the other side it'll say gain. These are gain knobs. So if I want to get louder here, if you can see me grab this, it's going to get a little bit louder in one headphone. Check. Well, I can't tell if it's getting louder, but you might. So, and I kind of messed that up. So that's the gain on that. So I'm turning up a little amplifier that's inside here, and it adjusts the gain. So the gain knob lets me adjust the amplification. So if you see gain or trim is another word you will see, that is talking about gain. So really the gain controls the amplifier. And to be really technical, we can call this a voltage control amplifier, a VCO. So as that is increased, it's increasing the voltage coming in, and it amplifies the signal. So the gain, it's very important. Hertz. Hertz is a unit of frequency, cycles per second. We've already said that. Headroom. Okay, in a cable or an audio device, the difference between the maximum level of the signal being carried and the maximum level of the device is capable of carrying without distortion. Now, that means what's the maximum level I can run through this microphone and into my gain without it distorting. Once it reaches that, there's a little room in there. That's what we call a safety area. And that's usually getting back, if I look, let's see if I can do that. If I go back to you see my meter over here? I have plenty of gain where I could be talking, where that level going up. If I get way up into the red, it's gonna start to peak. But I have plenty of headroom here, so I'm not really maximizing out anything. So there's headroom, and I'm probably not quite at the maximum level. I don't know if you heard my air conditioner go off or not. I did. And I heard my cat upstairs. There's a toy and this ball racket goes around, and sometimes I hear that. It go wrong, wrong, wrong. So anyway, all right. So moving on. So where are we? Okay. So the peak is the highest level of strength of an audio signal. Often refers to an unacceptably high level where the signal begins to distort. If I started talking really loud and turned up my gain really loud, then you would hear some crackling noise or some sort of distortion, okay? If you record, and we'll go over this when we start talking about setting gain levels, if you record into digital, the gain, and you go into that peak area and you actually go what we call an over digital 0, then you've got a problem. It's gonna sound bad. It'll be crackling, and there's nothing you can really. Well, there are some things you can do, but if you have the right software, but it's kind of a pain. So you have plenty of room nowadays with this 24-bit recordings. We have plenty of room, so you don't have to worry too much about peaking. In the old days, I tried to record as hot as possible, which means get that level up as high as possible. We'll get into that later. So to get away from the tape hits, and that's called a noise floor. Anyway, so here's another term, sample. In digital audio recording, thousands of individual samples are recorded every second, actually 44,100 times per second. These make up the digital audio signal. That's what a CD records at, 44,100 times per second, these little bits of information or samples. Okay, so we'll get into more detail when we start talking about digital audio, and so I'm going to go on a little bit. But just know that sampling is a way we record sound onto a computer. It records the analog sound or the audio and converts it to a digital number. That's all you need to know for now. Okay, stereo is an audio signal which is made up of two channels, a left and a right. So my audio signal is coming out of my left headphone and my right, so this is in stereo. If I pan to the left, this means I would adjust the level. I can't do that right now. But if I pan the level to the left, then I'd hear more in my left side, and my right side would be kind of be gone. So stereo means left and right, or two channels coming in, okay? As opposed to mono, which is only one. So you should be hearing me in mono right now. My voice is coming out of both speakers. It says opposed to mono. I'm looking at the thing. As opposed to mono, M-O-N-O. Thank you. Goes left and right. I mean, equally. You will hear left and right equally. Okay. So a transducer. It's a fancy name for things. So transducer, you can think of like, Transformers, the toys. They change from one form of toy to another. Like a truck into a monster, whatever, a robot, whatever. That's a transformer toy. A transducer is the same thing, in a way. Any device which converts energy from one form into another form. So microphones are a transducer. A transducer, so you're taking my acoustic energy, sound pressure levels that's coming out of my voice. It's going into the microphone. The microphone converts it to electrical energy, and that electrical energy is stored or sent wherever I want. So it's converting the acoustic energy into electrical energy. Likewise, a speaker or a loudspeaker converts electrical energy into acoustical energy. It goes the other way around. So that's a transducer. I'm changing from one form of energy to another. In this case, it's like most people don't say that. Say, hey, that's your monitor. They go, bring that transducer over here. They don't use that, but you might hear that it's a transducer. So at least you know what they're talking about. One form of energy to another. Okay, wavelength. The length of a wave is measured from any point on a wave to the corresponding point on the next phase of the wave. So we looked at that previous picture. Okay? Wavelength. All right, so that's the end of that part. I'm going to pause the video here and continue with something else. Okay, so those are just some basic terms. And again, on Tuesday, ask me some questions. If write them down and ask me questions. Questions are always a good thing. So those are just some basic terms there. There's plenty more, but that's all I need for you to know for now. And we're going to look at a couple things. We're going to look at studio monitors and room acoustics. So this is kind of related to what we just talked about. Studio monitors are what we listen to. Also speakers is another term that we would use, but the correct term is your studio monitors. What are you listening to? You're monitoring the sound. And then the room acoustics. I might play you a clip here too, but your loudspeakers in your room must play as a team to create a sublime sound at your sweet spot. Okay, so we're going to talk about this. I know some of us don't have the luxury of having a studio monitors, but if you do, I'm going to show you how to look at this, and you'll see why at Bowie State they're not exactly correct, but we're doing the best we can with what we have. But we'll get to that. So if you're mixing on headphones, I think I was talking to one of you guys about mixing on headphones. And that's probably where most of us are at. But anyway, we're going to talk about setting up a studio so it is it's set up properly, and then we're going to listen to it. So the listening position, okay? So what you'll find out, a listening position is the easiest way to start to locate your listening position is using what we call 38% rule. So with a grain of salt. So for the most part, we have a 2-channel listening environment. So I have a left and right here on beside me, right? And you will get the flattest, when I say flattest, the frequency is not boosting or cutting any particular frequency. So we're going to look at that particular graph. But if we look at frequencies on a graph, we want that graph to look flat as possible. So for 2-channel listening, you'll get the flattest low frequency response. So that's the low frequencies that you're listening to by sitting 38% of the way back from the front wall. Now my room is not quite there, but like in Studio B or Studio A over at Bowie State, if we move those speakers 38%, half, a little over, almost more than a quarter or a third of the way away from the wall, from the length of the wall, that's going to help us with our low frequencies, okay? Mine are not even close to that, but what I've done is I've acoustically treated behind it to help that reflection come off differently. So when I say flat, so this you have to get used to reading this graph here. So on the y-axis over here, this is decibels or amplitude, and the frequencies to the right. So the flatter the frequency you would have across here, the flatter your room is. And you want a flatter response to your room so you're not artificially coloring the room. If your room gets, if you have a lot of bass in the room and it sounds great, when you mix, but then you take it to someplace else, the bass is gone, so you overcompensated. So this dip, this would be, you would hear less low frequency, and that's because of boundary interference response. So anyway, so you have two waves that are coming off one's coming off the back wall, one's coming off the behind me, and then one would be coming off in front of me. So when they collide, then there's what we call a cancellation. Okay, so 180 degrees out of phase, you get what we call a phase cancellation, and I'll show you that in a second. So on the listening distance, okay, check the manual for your loudspeakers, recommending listening distance. Basically, this is what you want. So if you look over here, you have your center of your room, you have your speakers 38% away from the front wall, okay? And then you're going to be in an equilateral triangle. And then the tweeters, the small speakers, are going to have to be ear level. So if you look at mine are about ear level, and I'm equal distance to it from here, and I'm equal distance to it over here, and they're equal distance from in space apart. So they're equal distance from left to right from my head, and then equal distance, each one of these is equal distance, so equilateral triangle. Okay, each one is about 60 degrees here, so they're all equal. That's going to give you the sweet spot. Actually, that looks like a Pro Mix 01 right there, like what's down on my board. I just noticed that. See that? That up on the screen looks just like my board here. Huh. Never noticed that before. All right. But so then your room, and this is what I kind of want to do with Bowie State's mixing room. These are called, in the corner here, you have these, what they're called bass traps, so sound absorption material. Then so this keeps the low frequencies from bouncing around. And then you have something here on this wall to absorb the sound coming here so it doesn't go bounce back so much. And then also you don't get sound bouncing front and back, and you don't get sound too much bouncing left and right. So you're absorbing that. Think of it like a pool table. If you hit the ball, it's going to bounce around the room. So you really don't want those sound waves bouncing around, okay? But you can eliminate that for the most part by getting in this sweet spot here. And you can move your head back and forth a little bit in the sweet spot, and you can hear how that affects your bass, okay? There are tools. Where did I have that? This is, I don't even know if this link works anymore. Let's see. Let's see if this works. RoomEQWizard.com. Let's try that. We'll come back. So there, you see how that the equilateral triangle in your head is about the same height as the these are called tweeters up here. So that's where you want to sit. Okay. Speaker distance from the front and rear wall. Best The best way is to do it what they call a flush mount, like they have the speakers built into the wall, and that way they eliminate any reflection off the back wall, and so that's the best way. You're gonna have to have somebody put that in, or if you're a good carpenter or something, you can do that. But they flush mount the speakers into the wall. I'll show you a picture of that in a minute. This is the only way to completely remove the quarter wavelength cancellation caused by the wall behind your speakers. So they look like they're built into the wall here. Okay, so you're talking some money here to do that. Here's another example here. Flush mount. And so the position he'd be sitting here, these speakers are equilateral, so the distance from here. So you would have to measure that, figure that out. Okay. And this is explaining that quarter wall. So you have the original sound coming out and hits here, and then the reflected sound coming back hits here, and then they cross here. So if you're sitting right here, you're going to lose that low frequency right there. So it's canceled. I'll show you what a cancellation looks like. So put them very close to the wall, moving them. Put them very close to the wall and move the cancellation notch to a higher frequency. Okay, so you can do this by absorbing stuff closer. If it's closer to the wall and has absorption behind it. This is kind of what I do. Speaker placed closer, removing the quarter labeling cancellation to a higher frequency where it can be potentially treated. So at very close distances, only 4-inch thick absorption may help tame the cancellation knot. So this has to be pretty thick. Mine are 2.5 inches, so anyway. I do recommend speaker stands so they're not vibrating. I have, let me get my picture back up here. I lost myself. Alright, so if I go back over here, my speakers are on this stand. Okay, see these are rubber down here. So it doesn't vibrate. My desk doesn't vibrate, and it doesn't cause my desk to vibrate. Okay, so those are nice too. I didn't get those until a couple years ago. So again, there's a lot of stuff, but it's because I'm old. Alright. And we lost the big man. Alright, so you can apply acoustical treatment, and this is what I want to do. We're going to experiment a little bit in our studio since we're finally got some acoustical treatment coming in, so hopefully it'll get you there in a little bit. We'll be using some of that, so we're going to experiment, and you're going to help out with that. Start applying acoustical treatment as soon as you can, and it's actually come way down in price. So you can see in my background I have that foam, and I kind of just did it with a little bit of knowledge, like, okay, this is a flat surface here, and I put them up there. I try to cover my flat surfaces as much as possible. I clap in the room and listen to what it did to it until I got it dead as possible. So that's how I use mine. So, but there's other tools you can use. Your first reflection, okay, that's the point where it depends on your speaker. The first reflection is like, for me in my room, it's going to bounce off the back of the wall here, and then maybe off the door, and then get to my ear eventually. Okay, so that'd be a reflection. Okay. So if you move your speakers or listening position after treatment, make sure your reflection points are still treated. So you just have to look at where it's going to reflect. Okay, here's that room EQ wizard. Optimizing using acoustic measurements. The room EQ wizard to test your, I'm floating around here. Test your room as you try the different speaker listener configurations. Let's see if, okay, let's see if it happens here. So this is called Room Acoustic Software. I think it's some of this is free, so you can install it. Yeah, they're looking for donations, so you can install it and play it in your room, and it'll use it to measure. I'm not going to go into that right now because I don't know how much time I've spent here, but it's free software for room acoustic measurement. So just to know that that's there. Again, so if you want to look it up, it's REW or roomeqwizard.com. You do need a microphone if you're going to measure your room. You know, you can have this, like a Focusrite interface to help do that. We'll talk about the interfaces a little bit. If you don't have one, we'll see what the policy is. Okay, so that's one software we can look at. Let me go back to the lecture, see what else I have here. So yeah, that's the end of that. Let's look at a couple things, and then that'll be the end of this. Okay, so remember, I think I was talking about how you can like train your ear a little bit and understand. There's this program called soundgym.co, I guess, co. So you can actually train yourself. So, whoops.
Music producers and sound engineers are all using the same programs, same plugins, same equalizers and effects, yet only a create the deep-sounding tracks that touch millions. Why is that? Listening resolution.
Okay, so I don't know. Hopefully that didn't blow you out of there, but you can train on here online. So let's check it out. So you have to log in. I think I have a login. I'm not sure. Yeah, I do. Okay. So what you can do is you can find out. Like, let's say you want to figure out compression or pro. These you have to unlock. So there's some freebies, and they're probably down in the bottom if they were smart. Let's see. Oh, start training. Let's see. But anyway, you can listen to EQs and things like that. Play a game. Okay, so select the right amplitude difference in decibels. Okay, so this is where you check to see how you know what's different. So I'm going to do one. That's the first one, and it's going to play another one. Okay, so I'm going to listen to after gain. So was that a minus 16 dB less or minus 4? That was a minus 16 to me. Okay. Before gain. Now they're going to change the gain. So that's not very much, so I'm going to say minus 7. Okay. So it's going to get louder. How much? Because of a plus. That's only 2 dB louder, so you couldn't really hear the difference. So I can't really hear the difference. Okay, so you get the idea. So that's called Sound Gym. And if you didn't catch that, just rewind and look at it. What's the other thing I was going to show you? Let me pause here. Okay, so I've opened up my Pro Tools, and I'm going to show you some things that we covered here. First is we're going to look at some frequencies. Okay, so this is a plugin, what we call an audio suite plugin, and what I have here is a signal generator. So it's going to generate a signal. Hopefully it's not too loud. No audio was selected. Okay, so let me do that. Okay, so this is playing what we call a sine wave. a very smooth waveform, and this is playing at 1000 hertz. So this should make a lot of sense now, 1000 times per second. And at 20 minus 20 dB from the maximum value. So I'll show you that in a minute. So what I'm going to do is I'm going to render this, and it's going to create this frequency here. So let me just zoom in. And you're going to see if I get very close in there, you'll see a very smooth sound wave. Okay, so there it is. And now I'm going to back out just a little bit here. And then I can make this louder. So right now you see this little slider down here. Might be hard to see with it on the screen, but it says 0 dB. If I click on that, now I can raise that up, and notice how the waveform is higher, and you can see that. Now if I go in even closer, notice how this is the peak and this is the valley. It's exactly the same on both. That's what we call in phase. They're in phase. They're vibrating at the same time. That's a little loud. That's a lot louder, right? So that was 20 dB, 10 dB louder. So that was like twice as loud. So I'm going to bring it down so it doesn't blow you out. All right. Okay, so you're hearing that. So this is called clip gain over here. Really nice feature for Pro Tools, and helps you mix. Okay, so now see my level over here. It's telling what level's coming in off these meters. So let me just bring that down 2 dB, and I want to make that come out right at 0. I think you can do alternate click in, it might just go right to 0. Thank you. So it goes minus 2 dB. All right, so on my meter. There's other meters that can show you what's going on also. Since we're talking about meters, so then let's do this. I'm gonna pull another meter in here. Just slide down, and some dynamic. Let's see what we have. Sound field, phase meters, PAS meters. Let's see what happens here. It should pop up. Where'd it go? So this also giving me some readouts. And then there's a whole bunch of different meters. So we're going to learn about meters. So that's a nice smooth wave. Now I did mention, one other thing I mentioned was if something's out of phase. Okay, so what I'm going to do here, we don't need to see this, much of it anyway. What I'm going to do is this. If you look, well, I said before that this is in phase. So I'm going to take this. I'm going to split this into what we call two monos. Split into two monos. Okay, so now I'm going to mute this one. So these are the same waveforms. If I get in there closer, I'm gonna make so the waves look bigger, but they're not going to get any louder. Okay, so these are exactly in phase because this peak is happening. So this is the left and right, and they are panned. They're here, panned left and right. So I'm going to move. That means if they're panned left, you should be able to hear something coming out of just one speaker, and you can see it panned over to the left. If I pan to the right, both sides, it should be coming out of your right speakers. If they were vice versa and what you're hearing, then something's wrong. Okay? But anyway, we'll come back to that. So what I'm going to do is I'm going to put these both in center, so they're both coming out equally out of it. And I'm just listening to. I muted that. We're just listening to these two right here. Okay, so what I'm going to do is I'm going to take this sound. I'm going to slide it. Whoops, too far. It went away. Control Z is your friend, okay? So I'm gonna nudge it, and I didn't change my nudge value here. It's just my mistake. I'm gonna nudge this at, let's see what happens, 10 milliseconds. That's too much. It's moving, so it's moving exactly right. So I'm gonna move it by hand. Oh, I'm in wrong mode. I'm gonna move it so now they're exactly out of phase, right? One is down, one is up. So let's say this was a -3 here, and that's a +3, just for now. What does that mean? -3 plus 3 equals what? 0. Okay, so that's the volume. It sounds a lot slower. I mean, a lot lower. Let me just zoom back in. Let me look at my meter, is what I was trying to do. Look at the output. It's like at 0. I haven't changed anything. I haven't changed the volume. Now, as I move this, and I'm going to move it, nudge it, not 0.10. I'm going to move it like 1 millisecond. Okay, so let's see if you can see it move. Okay, it's moving, so the bottom was going to move. It's going away, right? It's exactly out of phase. See, it's playing back, right? Nothing's coming out because it's canceling each other out. As I keep hitting the plus, it's coming back in. I'm moving the waveform, so now it's back in phase. So then let's go in a little closer to see that. Actually, I didn't think I could get it all the way out like that. So now I'm going to slide. I'm gradually sliding it. It should be out of phase right there. See how it's out of phase? It's still playing. See this over here? I'm not changing anything. But now as I hold it down, it's sliding it. I ran out of time. Now it's going to get louder and louder because it's now in phase. So if I bring it all the way back in phase, that's going to be loud. So what happens is if I have two sound sources, one and the same frequency, and one arrives at the microphone at a different time, or you're hearing it, it cancels it out, and it's going to sound like, where'd it go? Okay, it'll disappear. This is drastic because this is exactly 180 degrees out of phase. So some of you probably were asking what the high frequencies are. I'm going to turn this down a little bit. I'll give you another signal processor here, signal generator. So we're going to increase it to like 5,000 hertz, almost 5,600 hertz. Okay, let's go down. So 808's down there, maybe down here, 46 hertz. I can still hear it in my headphones. I can feel that more than I can hear it. I can feel that because I can hear it. Wow, I can still hear it. I haven't lost low frequency in my headphones head. I do lose it up here. I'm going to turn this down as I go higher a little bit so it doesn't kill us. Whoops. Let me just do the level here. I still hear it. You should too. You're probably like yelling at me. I'm starting to lose it. I still hear it. I still hear it. I have to turn it up. I still hear it. I still hear 9. Good. Good, Cannon, go. I hear it. I still hear it. Okay, I start to lose it here. So some of you might still be hearing it. Definitely not hearing anything up here. Okay, so that's one way to kind of get an idea of what you're hearing through your headphones and what you can hear. But there's some other variables. This is not a scientific thing. There's some variables here, okay? First of all, how well do your headphones play back is one of the things. And every little thing in your system has to be able to play those frequencies back to tell. And then if you can hear that. So it's not a perfect scientific experiment, but that's what it looks like. And let me just give you one more so you can look at the difference in wave forms. So I'll record a waveform on this one at a different frequency. Sound generator. So we were at 1,000 hertz before. So let's go. Let's record. I'll put a little 3,000 hertz, and it should be a lot. See how it's closer together? The waveforms are closer together. And then if I generate one here, and let's go down to 40 hertz, and I'll render that. So the waveform's a lot longer, right? A lot wider. Longer, I should say. Okay. So this was like 5,000. This is 5,000. This was 1,000, and this is like 56. And then basically, you don't even see a whole waveform here. Let me just get a little wider. So there's down, and the full generation down up, so it'd be this length. That's the length of it. Okay, so anyway, hopefully that clarifies some things. Write your questions down. I'll be glad to try to answer them on Tuesday, and you can reread this. Just the terms that we covered in the first part of the class about gain, signal, frequency, pitch, amplitude, decibel. Those are the things that I'm looking for you to understand now. So anyway, have a good weekend, and thank you for indulging me in this, and be safe, and I'll see you on Tuesday.